Hi, welcome to the session on probabilistic project management. I'm Alejandro Garcia. I'm founder of Hack Academy, Sublogit.mx, and Big Data Mexico Group. I'm also professor of the Master in Software Engineering of CEMAT Zacatecas. I have over 20 years of experience in the software industry, from developer to architect, project management, and now professor. I've been founder of 3 different software companies, and I have several certifications from LeanKanan University about the Kanban method, and from Scrum Alliance about Scrum and the different roles there. So let's think about a little bit. What is project management? To me, project management is answering 3 fundamental questions. When is it going to be done? That's the delivery date. And why is it going to take that long? Second question is, how much is going to cost, the forecasting? And why is it going to be that expensive? The third question is, who do I need in my team in order to finish the project? And that's the staffing question. So the current approaches to answering these questions have been to use, in the agile world, we use a sprint speed, the velocity of the sprint. And in PSP, TSP, they use lines of code and linear regression in order to allocate and forecast time. However, we know that these approaches aren't enough, because in this report of the Standish Group, we know that using waterfall methods or rigid methodologies as PSP, only 14% of the projects are finished on time and on budget. 57% are finished challenge, which means they change the scope, the budget, or the time, and 30% are cancelled. In the agile world, the situation is half full, half empty, because 42% of the projects are finished on time and on budget. 49% are finished either out of time or out of budget, but they are finished, and only 9% of them are cancelled. So the good news is that with Agile, you can be 3 times more effective than with Waterfall. The bad news is that it's still a matter of flipping a coin to know if your project is going to finish on time and on budget, or if it's going to be challenged. So what the proposal is to use Monte Carlo simulation, and in order to do that, we are going to use this very nice demo made by Larry Maccherone. So let's start here. In the beginning of a project, let's say we know that we have 40 requirements, 40 use cases or user stories, and then in the first week we are going to have new requirements. We are going to discover them, and then on the second week we are going to discover some more, and then maybe not, and then more and more, until there is a point where requirements stabilize. However, in that same weeks or iterations, what we actually develop is this red line. And so the first week we may develop one requirement. The second week we might develop 5, then 2, then 5, then 2. So what we would use would be like the sprint velocity in order to get to see when are going to finish. So the sprint velocity is this blue line right here, and what it means is basically an average of our speed per week. The problem with an average is that by definition, in an average, some of the values are below average and some of the values are above average. So what could actually happen would be that we have a very bad week, and then in fact we produce as much requirements as this one, and then another bad week, and many bad weeks, and we will actually finish the project on this date. Or we can be very lucky and in fact do as much requirements as we did in this week, and then another good week and another good week, and we can actually finish on this date. So neither of those 3 lines is actually real, right? Not everything is going to be bad and we're going to finish super late, but not everything is going to be good and we're going to finish early. What is most likely to happen is that we are going to have a path of good weeks, bad weeks, and so, and then we can finish on this date, or we can have many different paths. We can have 10 different paths and finish in either one of these, or we can actually run a simulation 100 times, and then we will finish that different paths lead to basically the same weeks. So, for example, if the question is when are going to be finished, we can answer with 90% chance we can finish in this week or early. This is what this graph means. And this is Monte Carlo simulation applied to project management. So the next step is how can you use these simulations in our projects. In order to do that, we can use a project called KanbanSim, developed by Magennis, that basically represents a project. Let's say like this one. I want to show you this project has a backlog with 22 items, and there are 0 completed. In order to finish this project, a requirement, an item, must pass through selected, analysis, development, test, and then it's ready to deploy. You know, like if we deploy every 3 days to production, and then it's going to be complete. So what would happen? Well, the first day we'll take the user story 0, 1, 2, 3, and 4, and the 0 and 1 will go straight to analysis, and the 2, 3, and 4 will stay in selected, because those are the ones that we are going to develop in this iteration. Then the next day, you know, the story 0 and 1 are being worked in analysis, because doing the historical data, we know that the analysis story takes either from 0.5 days to 2 days there, and these times are selected randomly, and randomly decided that it's going to stay there another day. Then by the third date, the story 0 and 1 are finished, and they go to development, and then now 4 and 5 are going to spend, you know, a random time of analysis within our range, and so on. So this is how it it's developed, and then the story 1 is finished and it's ready to deploy. And since we deliver every 3 days, on the day 6th, that story goes to complete, and then the 0 and 4 stories arrive. That's pretty common. Now, when it gets more interesting is when, in fact, we have a bug. A bug wasn't you know, planned, but we, based on historical data, we may discover that a bug takes, you know, in order to be fixed, takes either from 0.1 day to a whole 1.5 days in order to fix a bug. So it creates a bug randomly and assigns to it a time that is going to spend in development, and then it's ready, you know, to test and send to production. Then we have a blocker. A blocker is like a dependency on, you know, something that is outside of the scope of the project. Maybe a special equipment or a special technician that it's, you know, a database administrator that is not available and it's not part of the team. And those also happen. We also have expedites. With expedites, you know, an emergency came, and we must deal with it. And finally, we have these green tickets, which represent under the scope. You know, projects always get more things to do. And so this is the simulation of one path of the ones that we saw in the previous animation, right? And by the end of the project, turns out that we actually have finished 40 items. Do you remember we started with only 22, but with the added scope and the different and the debugs and the blockers, actually we finished in doing 40 things. So, but that's only one path. What we want to create is to simulate 100 paths, and this is what it does. Here we have what happens with well, these are 25. With 25 paths, in 95% of the cases, our project is finished in 39 days or less. So this is very interesting. For example, if the customer tells us we want the project in 30 days, we can say that's impossible, because only 80% of the time we have finished it in 33 days or less. If on the other side the customer says I want the project done in 50 days, then we know we are in pretty good shape, because 100% of the simulations, the different paths, we have finished it in 42 days or less. So this answers the first question, when is it going to be done? Well, according to the simulation, in these dates. How much is it going to cost? Well, this is very interesting. For example, here we know that it's going to take 88 work days to finish the project. That's going to cost us $576,600, and it's going to be delayed the project for 21 days. So we are delayed. Now the next one is, well, then what can I do? Well, for example, let's say a developer says what we need to do is to implement continuous deployment. So in order to represent continuous deployment, what we can do is we get rid of the ready to deploy column in our simulation, and now our simulation means that when we finish testing, the tickets go directly to production. So if we do that, how does it behave? Well, turns out that if we do that, we are going to finish with 95% in 37 days or less. So this is pretty good. Remember, we were at 39 days, and doing continuous deployment, we finished in 37 days or less. And how does that affect our forecast? Well, turns out that that's going to be 35 work days. It's going to take us $132, and if you remember, we were at 577, and then and we're going to be delayed only by 16 days. So that's pretty good. We've are delayed by less days, but still not good enough. We need to be able to deliver on time. What else can we do? Well, we could add more developers. That's always an answer, right? Add more developers. So, but do we really need developers? Do we really need more people here in the development column? Or could there be another answer? Well, we can use this tool right here called the staffing button. And what this does, it simulates what would happen to the project if we change the people in the different stages of the process. So here it says its suggestion. It says you currently have 2 analysts. If you change those 2 analysts to 3, you can expect a 22% reduction in the average time of a requirement. Then if you change from 3 analysts to 4, you can expect another 5% reduction in those times. After that, what you should use is add more testers. You currently have 3, you could add a 4th, and then you can change an analyst from 4 to 5 again to get the last reduction. If you can see, it gives us the suggestions in order of their impact in the interval time. So, all right, let's do the suggestion. Let's hire another 2 analysts and another tester. In order to do that, we go here, and we say, I want, instead of 2 analysts, I want 4 analysts. And instead of 3 testers, I want 4 testers. That changes the board. You know, see, now we have more analysts and more testers. And that changes also the results. Now the results are that we finish with a 95% percentile in 25 days or less. In our forecast, we can even see that we finish in 22 work days. It's going to cost us less because, you know, even though we have more people, we are using them less time, and it's going to finish 1 day early, 1 day to the commitment date. So that way we know the answer to the third question. which people do I need on my team? We don't need more developers, actually. What we needed was more analysts. That's where the bottleneck was. So, in conclusion, I think in order to create these simulations, we need to model our process. We need to, which means basically define the columns that we need we have in our in our process. Then we need to calibrate it, which means based on historical data that we can extract from Jira or whatever book tracking software we are using, we calibrate the times inside that column, and then we can simulate. After that, we monitor if your simulation is valid when the project is being done, on real life. We monitor if the real project is between the boundaries defined in our simulation, and we adjust the simulation if the real project is not behaving like we simulated. The next question I often get is, how many samples do I need in order to create these simulations? Well, turns out not that many. If your project is measured in years, then you should have the data for the last 11 weeks. If your project is measured in weeks, then you only need the data for the last 11 days. And in fact, what you need is the last 11 user stories, sampled randomly, and the start and end time of those user stories. This approach was developed by Troy Magennis and Larry Maccherone and Alexei Zheglov of the Kanban University. And as you can see, it provides a different answer, a probabilistic answer to the 3 fundamental questions of project management. And thank you very much.